is a question from GATE 2020 EE paper in which we are given a third degree polynomial with arbitrary coefficients a, b, c and d, wherein a is not equal to 0, and asked to find out which of the following statements is true. Below the question you will find the title of the NPTEL course or video that is relevant for this question. Here is a bit of background that you need to solve this question and understand its solution. You'll need to know what a polynomial in one variable is. You'll need to know what its degree is. You'll need to know what the root of a single variable polynomial is. And you will need to know some facts about polynomials with real coefficients. So let us investigate why in this problem only option A is true. We are given that the coefficients are real and it's a third degree polynomial where a is not equal to 0. The first option says coefficient d can be chosen to ensure that x equal to 0 is a root for any given a, b, c. Now let's look at the solution. If d equal to 0, the polynomial becomes ax cube plus bx square plus cx, from which x can be taken out. So now if I were to substitute x equal to 0, then it would be 0 into something which is equal to 0. Clearly, x equal to 0 brings the polynomial to 0, which means the polynomial has a root at 0. Thus, option A is true. Next, no choice of coefficients can make all roots identical. Now, this is not true, but for a very particular counterexample, which is the choice of a, b, c, d equal to 1 followed by all zeros, resulting in simply in the polynomial x cube. And you can see that x cube equal to 0 has 3 repeated roots at origin, that is 0. Thus, I was able to get a choice of coefficients which make all the roots identical. This option is false. Similarly, for option C, what we can see, actually no, for option C, we'll have to do something different. It says that the coefficients can be chosen to ensure that all roots are complex. But we'll now leverage one fact from, we'll now leverage a property of polynomials with real coefficients, of which our problem says it is, that if R is a root of a polynomial with real coefficients, then R conjugate, which is the complex conjugate of R, must also be a root. That is, all non-real roots must come in complex conjugate pairs. So in our case, we have a cubic polynomial. That means it must have at most 3 unique roots. Let's, for the sake of explanation, consider that the roots are unique. Let's say that the root R1 was complex, right? The goal is to make all roots complex. So let's say root R1 is complex. That means root R2 is its complex conjugate. For instance, let's say that root R2 is its complex conjugate. So therefore, it cannot be that root R3 is complex. It has to be real, because complex roots must come in conjugate pairs. And since R3 doesn't have a conjugate pair, it must be real. Thus, we can see that option C is also false. Finally, we conclude with option D, which says that C alone cannot ensure that all the roots are real. And similar to option B, we construct a counterexample for this statement in the form of the polynomial x cube plus cx. For x cube plus cx, making c equal to 0 reduces the polynomial to x cube, which, as we saw in the proof for polynomial b, has 3 repeated roots at x equal to 0. So therefore all the roots are 0, which is a real number, and so therefore all the roots are real. And thus option D is not true. So therefore the only correct answer for this question is option A.